We, our family, we're trying to take a proper fraction and break it down into its most basic pieces, which we call partial fractions. You're welcome. We are taking a proper fraction. Question, what's the difference between a proper fraction and an improper fraction? We talked about this a little bit on Friday. A proper, I could even say a proper rational function and an improper rational function. What's the difference? Joe. I love it, but you have to specify that. Because some people would be like, ooh, 3 terms on top over 2 terms, which isn't always improper. Or they could think, that one has 100, that one has a 5, improper. Let's give them a chance then, Joe. Hold on. Can you change it? What number? You're right with the numerator denominator. You're right with numerator being bigger, but Joe, what?
When the power on the top.
Yeah, so when you're thinking numbers, think power, because we have to say the degree. So the numerator's degree is less than the denominator's degree. And that's the definition of degree. So Joe's giving us the definition of degree. Degree is the highest power of the top, the highest power of x, or the highest power of the variable terms. Degree is defined to be, so we don't really need to go into that. But if the degree of the numerator is less than degree of denominator, it's proper, and that, as soon as it's proper, we can go to partial fractions, or at least try for partial fractions. I think I give you guys 1 in homework. Ooh, spoiler alert. I think I give you 1 in homework that cannot be broken down. Like he's as low as it can go, and there's no other way to break him down. That's something to keep a lookout for. He is a proper, and you're like, I got to break him down, and then it's like, wait, but I can't. Some proper rational functions can't be broken down. They can be broken down, go to partials, and then improper is the degree of the numerator. What's left besides less than? Greater than or equal to. So if I have a line on top of a line, improper. If I have a quadratic on top of a quadratic, improper. And it looks weird, even Calc BC kids. You heard Maggie talk a little bit about the comparison test, and it's in this big old topic of convergence and divergence of series. But they saw some problems that had improper fractions that they didn't recognize, and it messed them up, ironically. One little baby thing from Precalc that they forget, and it can mess up a whole problem. So greater than or equal to. Now, can you guys look in your notes? What do we do if we have an improper? But you can't make an improper proper. I see what you're saying, Joe, and I half agree. You can't just say, hey, top stronger, all of a sudden I'm going to make the bottom stronger. Like that's going to change it. Divide. I need to divide, that way I can split up into the whole pieces and the proper pieces. Because if it's top heavy, and we looked at numeric values of this on Friday, if it's top heavy, and I can do a quick example of that like, oh, I just dropped my lotion, 11 over 5. Sorry, I'm sitting down because I'm tall and I don't want to block all of your guys' vision. 11 over 5. Improper, true? So if I was to make it proper, I am going to have a proper fraction of 1/5, right? 11/5 is not 1/5. Yeah, we have to divide out the whole pieces. Isn't it 2 whole and a 1/5 extra? Does that make sense? And technically, even though we write it like this when it's numeric values, couldn't we do plus? Like it's 2 and 1/5? It's 2 in addition to 1/5? That's what we're going to do with rational functions when we divide. So the long story short in this one is that there's an in-between step. We have to, first of all, use long division. We have to divide into whole and remainder. And technically, I put a slash, sorry, that looks like division, I suppose. Whole plus remainder, kind of like 2 plus 1/5. And the remainder is going to be proper, or a proper rational function. This is going to be proper, and as soon as it's proper, what can we do? Take that piece that's a partial, and we still need the whole, like it's going to be a part of our answer, but we take that remainder and say, okay, let's go ahead and break you down. So all of that to review how we look at problems. Do you guys see why in this one we did not divide? Because it was proper. Why? That has a degree of 1 and this has a degree of 2. If they were both 2, you needed to divide first. But since they're not both 2, that one is lower than sweet. Let's go. Let's go where? Let's go to partial fractions. So someone verbalize the first step, the idea I did. What direction did I follow? Nope, not quite. You're close. That's the second step I did. What's the first step I did from there to here? I factored the denominator. I guess yours is actually the third step. I factored the denominator, step 1. Didn't I have to write this? Where did these come from? I factored the denominator, step 1, right? What was step 2? Good. One way is thinking you split up the denominators. What the book would say is that I formed partials. Now hold on, can we look at homework really quickly? Because some of you started it and some of you will still need to start it. But can we look at the very beginning of homework? This is 7, can you guys check 4, right? Yeah, okay. At the very beginning of homework, do I have it open? No, I don't. This actually messed honors up back when they were doing it. Oh, that's not homework, sorry. Here we go. There. Very beginning of homework. Can you guys look at the directions real fast? For the first section, which is numbers 5 through 8. You guys know it's after the vocab. What are the directions? These are the rationals, the rational functions, with its decomposition. Are there numbers in the A, B, and C spots? So did they have to finish the problem? Do you have to finish the problem to match? Look at what we did a second ago. This is a finished partial fraction decomposition. A finished partial fraction decomposition has what? A's and B's or numbers? You see it? But some of homework is just going to be like, do you even know how to start? Does that make sense? The A's and B's are just how to start. So the very beginning of homework actually asks you, do you know how to start? How would you? Oh, man, they were so nice to you, too. Because look, isn't it already factored? So isn't it pretty quick to say, well, he must have come from those two guys, right? He must have come from, well, he's the only other one. Well, that's weird. There's an x and an x squared? Huh. Well, he must have come from, well, that doesn't make sense. He must have come from this one. Oh, that's weird. There's a bx plus c. You're kind of like learning as you're going, as you're just starting this off. Oh my goodness, I just did all of them because there's only one left and it must go with, they must have factored. Anyway, man, giving answers right and left. But what's the second section of homework? What do the directions say? Yeah. Matthew like honed in on what you really need to pay attention for. Because it says writing the form of the decomposition. So when I say the A's and the B's, we're forming our partial fractions. We're saying, okay, this is what I need to figure out. We're just starting the problem. So there were some honors kids that I forget how many I gave them in here, but they sadly solved this from the very beginning to the very end. Then they went to the back of the book and they were like, A and B, are you serious? So this is just saying set it up, right? But now what's coming in this section? I mean, that's good, Matthew, but this one's important to read all the directions. They want you to write the partial fraction decomposition. The form? No. The decomposition, which means from here on out, I'm not saying necessarily, ooh, improper. Look, they're saying hint, 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 divide. Anyway, sorry, coming back. From here on out, for the most part, you're going to actually be starting and finishing. So up to this point, just A's and B's, just splitting up. If I were you, I would use this matching section up here to kind of help you form the partial fractions here or make sure you're doing it okay. But now we're in like exercises 17 and beyond. When I say, great, I formed my partials. trying to tell you why I use this vocab. I formed my partials. Like I have the form of them. I have what they should look like, but now I need to go ahead and find A and B. So Matthew, now I'm ready for your step. First, I factored. Second, I formed my partials from the factors. Third, go ahead, Matthew, what did I do? I multiplied both sides by the common denominator, which should be the same thing as the entire denominator. Does that make sense? The common is the entire. So I multiply both sides. For some of you, like once we do more examples, you might just get in the habit of putting this next to both of them. It's easier on some of your brains just to be able to cancel and see what's left, to cancel and see what's left. But then what did I do? I multiplied both sides by the common denominator. That's what was going on right here. Not just on one side, but also on the other. And then I got this. What's all this color coding for? Terms. What about the terms? Yeah. Do you guys remember once upon a time we were doing, people who are listening on the video are not seeing what I'm doing on the whiteboard. Let me do this. Just because I don't really want to put it in your notes. You don't need to have it in your notes. What is this? Huh. Okay. Remember once upon a time we had something like a complex number? You guys remember a plus bi? Whoops, sorry.